3.7 is quite a big one. It goes on and on, so let's get cracking with this. And I think it's a good topic to be good at, so if you're not very strong on this, please practice. There's a lot of nice marks to be had in the paper for statistics. So calculating the mean. That's not to be confused with the median, which is the middle number when it's from lowest to highest. The mean is simply where we add up all of our numbers. In fancy mathematical terms, we add up our numbers and we divide by how many we've got. So I know I've got 6 numbers, and if I add them all up on my calculator, I should get 2.5 plus 4.5 plus 3.7 plus 3.1, 3.8 plus 3.4. I should get 21 divided by 6 for 3.5. So that's your mean. Yeah, add them all up and divide. Nice, easy numbers there. And then we do standard deviation. Now, standard deviation, you're given the formula at the front, which I don't actually have because I've had to crop this because my computer is being weird. But you've got your standard deviation in front. I like to use the standard deviation formula of x minus x bar squared divided by n take away 1 square rooted. Okay. If you use the other one, fair enough, but I prefer that one. Okay. The thing you've got to do first is draw a little table out to work out this value. Okay, it looks quite confusing, but it's not really. It's kind of fair. Okay. So you've got a little table like this. Keep using the wrong thing. X, you get x minus x bar, and you get x minus x bar squared. Just like here. So we're trying to, just like here, we're just trying to get to the x minus x bar squared. And at this point, I think I would put everything in a nice neat order because then I can spot if there's a mistake. Okay, so you don't have to do this. I think it's quite nice to do 3.1 and 3.4 and 3.7, 3.8 and 4.5. So I know that my x bar is the mean, that's 3.5. So you don't have to write the sum every time. You could write if you wanted, 2.5, take away 3.5, and each time you're doing your 3.1, take away 3, you can do that if you want, but you don't have to. So I'll just show the sum for those two, just to show you it. But for the rest, I'm not going to do it. So that's negative 0.1, and then it changes, doesn't it? Now you get positive 0.2, 0.3, and 1. Now at this point, you can check to see if you've done it right because this column, should add up to 0. So if I look, I've got negative 1, so that's negative 1.5, and this one is positive 1.5, yeah? So that's good, that means I'm on the right lines, right? If you've got that, you're thinking you've not made any mistakes yet. Not a guarantee, but it's a good bet. And then you're doing this number squared. So negative 1 squared is just going to give me 1. And don't forget, when you square numbers, they're all going to come out as positive. Okay, 0.1 times 0.1 is going to come out as 0.01, 0.04, 0.09, and 1. So you could do that in your head if you wanted, but you can just double check your calculator. Okay, don't forget when you multiply decimals, 0.2 times 0.2. Just don't forget that's the same as doing 2 times 2, which is 4. And then you see how many numbers are after the decimal. Well, there's 2 numbers after the decimal, so I'll have 2 numbers after the decimal in my answer. Yep, same as that one. 4 times 4 is 16. The question would have 2 numbers after the decimal, so I'll have 2 numbers after the decimal. Okay, so you can do that in your head if you want. Then we're going to add all that up. So I'm going to say I've got 1 plus 0.16 plus 0.01 plus 0.04 plus 0.09 plus 1. So that's going to give me 2.3. So we're getting there. I just need to substitute that into my formula now. So I'm going to say 2.3. That's the sum. That is the sum of all of the x minus x bar squared. And sorry, classic me, I forgot my little symbol there. So it's the sum of all the x minus x bar squared divided by n minus 1, which is 5, and it's all square rooted. So that comes out as 0.678. Okay. So for this one, it's a nice little table you just have to do. Very prescriptive, and you don't even have to remember the table, you just have to remember you're getting this number, and you can see it kind of works back quite nicely, doesn't it? Well, I'm not squaring it, and then it's just the x's. So try and remember this little table. in your head, and honestly, it will really, really make your life quite easy. I prefer this to the other one. Okay. Don't forget to do big square root as well. People forget that. Forgetting that's not ideal, but I knew what I meant. But don't forget square root. Okay, so that's us worked out the standard deviation for the birth of baby weights in 2017. This now says the birth of baby weights. So I'll just, I'm going to say 2017. Okay, I'm just going to write that down. 2017. So you get the x bar and you've got the standard deviation. Now the mean we said was what did we say, 3.5, and the standard deviation was 0.678. So what I would do is write that next to the 1987 value. So the mean weight was 3.4 and the standard deviation was 0.95. So what can we say? Well, we can say that on average, and we have to say on average for this bit, on average the weights of the baby is increased, from here to here. So on average, the weights of newly born babies, try and keep it as close to the question as you can. On average, the weight of babies has gone up from 1987. It's higher, isn't it? And you can even tie that in and just say, 3.5 is bigger than 3.4. So you can't see the last end of that. Watch over a wee bit. Yeah. And what about the standard deviation? Well, the standard deviation's gone down. So that means that, you have to say on average this time, the weight of the babies is more consistent, isn't it? It's more consistent than 1987, as 0.678 is less than 0.95. So there's the two things you need to think about doing this. It's comparing the averages, comparing the averages and comparing the standard deviations. So you can see on average the babies are more heavy, that's fine. So make sure you see it on average, and it's the weight of the babies we're looking at. Make sure you get the English in. It's gone up, and this is just a bit of extra, but I like to have as much in as I can to show the marker what I'm talking about. And this has gone down. So what does that mean that's gone down? Well, if your standard deviation has gone down, it's more consistent. The smaller the standard deviation, they got the word deviation, you're not deviating as much, everything's closer together. Okay, so not on average this time, you don't have to say that. You just say the weight of the babies are more consistent than 1987. So very consistent here, less consistent here. Nice one. Have we got time? No, I think I will do this on my next video.